As we've learned, plant breeders have a number of tools in their toolbox. Sometimes, which tools to use to tackle a specific problem is clear. Other times, trade-offs have to be considered. How much time will it take? How expensive is the tool? How likely is it to get the job done? Is it safe for people and the environment? Are there negative consequences? Are there alternatives? Like all scientists, plant breeders make informed decisions when deciding the best tool to build a better plant. Let's take a look at a real-world scenario when plant breeders had to choose the right tool to tackle a global threat to food security. Globally, wheat is the most important food crop. More than 4.5 billion people worldwide depend on wheat. Forecasters suggest that demand for wheat could soar by as much as 60% by the middle of this century. The ability of the world's wheat farmers to meet current and future demand for wheat is threatened by many factors: climate change, drought, urbanization. Some of the biggest challenges farmers face are fungal diseases, especially the highly virulent populations of stem rust that were identified in East Africa in 1998. At the time, these super strains of stem rust threatened as much as 90% of the wheat planted around the globe. Spores of the new races of stem rust were identified from East Africa all the way to the southernmost countries of the continent. The pathogen also moved north and east. In 2006, it made an alarming jump across the Arabian Strait to Yemen and subsequently as far north as Iran. In its path were the breadbaskets of South Asia and China. The food security of hundreds of millions of people was at risk. Let's look at what happened when the world's wheat breeders rallied together to choose the right tool to protect the world's wheat. Ronnie Kaufman, the director of the Durable Rust Resistance in Wheat Project, took on this challenge. He tells us the story.
In 1998, a new race of wheat stem rust, which is the source of the great biblical plagues, was discovered in East Africa and threatened the entire global crop of wheat. So breeders and pathologists had to make urgent decisions to deal with this. They had to think about sources of resistance, because resistant varieties are really the only answer. Pesticides, fungicides can be used for the short term, but in the longer term, resistant varieties are the only answer. And then the question is, what method to use? There's the conventional approach, which is widely utilized throughout the wheat breeding world. This is a known approach with a known outcome and a known duration of time. It's reliable. The con is that you wouldn't be able to quickly combine a large number of genes. So the GMO approach would potentially, through a transgenic means, allow you to combine a number of different genes. But the disadvantage is that the regulatory challenges, especially in a number of developing countries, are not consistent from country to country, and compliance with regulatory requirements could be a very time-consuming challenge.
As Dr. Kaufman says, the breeders working to protect wheat from UG99 had to make some informed choices. To deliver new resistant lines of wheat to vulnerable farmers, should they employ a GM approach, allowing them to efficiently stack several new resistance genes into their plants, or to use a more socially accepted conventional method? Put on your plant breeder hat for a moment. Which path would you choose?